All right, welcome everybody to Ignatian Values Day on religious and loving. My talk today is going to be on water, and specifically it's going to be on the interdependence of water and the emergence. So let me take you through some of the flow. We're going to start out looking at interdependence and emergence. We're going to flow through some of the science, from the bio to the chemistry and the physics. And we're going to focus on not the emergence, but more the emergency and some of the problems that are associated with that. From there, we'll move to environmental and social justice concerns, and then follow that up with some solutions. Solutions both from nature, or biomimetic solutions, ones that are through design, and then address some of our personal responsibility in water-related issues. As we're going through it, try and think of some ideas you might have, all right? Any kind of questions you have, let's hold on to them until the end. All right, and maybe we'll try this kind of thoughts instead. All right, so what is interdependence? All right, we want to think about life being mutually dependent upon water. All right, more so than any other substance on Earth, life needs water. Above oxygen, above food. Here we can check out some pictures on interdependence with narwhals above the Arctic Ocean, polar bears swimming, a kittiwake above a glacier in Svalbard, a little seal pup popping its head up, hopefully not to encounter one of those polar bears. Waterfalls in the rainforest, ice plates or jellyfish. And then the idea of emergence. What does that mean? Mostly it's complexity arising out of simplicity, or to emerge, to come forth, both on the evolutionary scale or in the developmental scale. Water emerges from both the simplest of molecules, H2O, into the largest of waves. Flocking with birds and locusts, they emerge, and they emerge through the simplest set of rules without a leader. Right? Here are some rules. Stay at the right distance, align with your neighbors, and avoid predators. All right, let's go ahead and try it. So we're going to get the wave. So we can emerge as the wave here, a wave of humans, without rule number 3, right? We won't have any predators. So let's go ahead and do this. You don't even have to stand up, but we'll do the microwave. Let's try and circle it around. It's going to look like this. Okay, so we'll start up here and circle out. Ready, go. No, circle. So we got to come around, right? Not all at the same time. So we got to let it flow. Let's try one more time. Ready, go. Bring it back. Stop, reverse. All right, I think we got it. Ants emerge, right? Even to the form of a superorganism. The game of chess, a few simple rules, and yet infinite number of possibilities. Hurricanes and weather patterns. Even cities like Chicago. The stock market, consciousness, and life. So the earth was formed out of water and by water. Our goals for today. We want to concentrate throughout on being religious and loving. Right? The idea of educating, reflecting, and action, deepening our awareness, and simple living. Right? Leonardo da Vinci said, simplicity is the ultimate sophistication. And so we look at bioenergetics for our source of interdependence, and we see photosynthesis, cell respiration, and the importance of water. A rhino and the grass that it eats. Photosynthesis, cell respiration, water being split with the energy of the sun, water being formed inside of our cells in the mitochondria. Let's quick run over the stats. The Earth had 71% water. You? Maybe 50 to 70% water. I did the calcs on me. Works out to about 18.9 gallons. 5 plus 4. So that's the amount of water that I've got in my body. Works out to about 150 or so pounds. Right? 18 of those. How much do you need a day? Maybe 2.5, 3.5 liters. Or get your 8 cups. All right, we want to look at cycles and the idea of recycling, and that the water cycle is fixed. We've got a certain amount of water on Earth, and it's been that way for a long time, and it is stable. We want to see analogies to this cycle, follow from where it begins to where it ends, focus on its liquidity. We see that it's a closed loop. Water moves from where there's more to where there's less, from high to low, as in a waterfall. It also moves from high to low concentration, as in osmosis. And so the movement of water governs the cycles of the earth, the cycles in an animal, and in our cells. We see this as emergence. We see it as a symmetry of scales, bottom up, creating complexity. And we see that the whole is greater than the sum of the parts. We see the self-similarity as you would in a Russian doll. And so if you peek back at these different layers, from an atom to a cell to tissue to organs to organism up to biosphere, you see that repetition of structure as you would in a Russian doll. And so we can compare these systems on the biggest scale, the Earth, down to the form of life that we know, the organism, you. Clouds filtering the water as our kidneys filter the water inside. Rivers and streams are the network of arteries and capillaries and veins in our circulatory system. We move into the earth and its rock and groundwater as it detoxes and cleans water, much as our liver cleans water in our system. Swamps and wetlands, analogous to our lymphatic system. And then we have the origin of life itself. Life beginning in water, emerging out of water. The multicellular organisms taking the ocean within. We see commonalities and similarities in our blood. If you were to look at the composition of the liquid part of our blood, it would be much the same as the components of salt water itself. And so we move to the science. And we'll get you a little bit back to integrated 1 and maybe a little integrated 2. We see the origins of land animals. We see mythological stories. The earth on a turtle's back. We got the primordial soup theory. Newer research showing that in fact life probably didn't exist first in the Campbell soup can, but rather at the bottom of the ocean at deep hydrothermal vents. And we see again the ocean coming within. And we started off in water. And by means of water, we give life to everything. And so we search for life, first by searching for water, and also liquid water. And so recently we sent rockets into the moon to discover, in fact, that there was water there, searching for water and therefore life on Mars and throughout the universe. And so the question is, why water? Water is life. It shapes life, it shapes our world and our bodies, and life happens in water. It connects us. Water is life, and life is aqueous. And so why liquid water? We focus on the flow, the flux, and the movement, and the way in which water shapes and carves both the geology of our lives and our earth and the intricacies of our bodies. Henry David Thoreau said, "The finest workers in stone are not copper or steel tools, but the gentle touches of air and water, working at their leisure with a liberal allowance of time." And Lao Tzu said, "Nothing in the world is more flexible and yielding than water. Yet when it attacks the firm and the strong, none can withstand it, because they have no way to change it. So the flexible overcome the adamant, the yielding overcome the forceful." We see water as it shapes the patterns of life through fractals, irregular, self-similar, repeating geometric structures. Mandelbrot said, "Clouds are not spheres, mountains are not cones, coastlines are not circles, and bark is not smooth, nor does lightning travel in a straight line." You can see this from space and satellites of an estuary, a delta, neurons, fractal broccoli, coastline and ice shelf, trees, ice patterns. the branching of our lungs from bronchioli to alveoli, to the veins of a leaf, to river delta in Bangladesh and the Mother Ganges. Chief Seattle said, "The shining water that moves in the streams and rivers is not just water, but the blood of our ancestors. And the blood that runs through our veins is the water that runs through their veins." Perhaps most beautifully, we see it in stalactites and stalagmites. And Eduardo Galeano said, "Stalactites and stalagmites spend thousands of years reaching down or reaching up, drop by drop, searching for each other in the darkness. It takes some of them 1,000,000 years to touch. They're in no hurry." And so we're back to why liquid water and its emergent properties. And we'll cover these quickly for the rest of our science piece. And so we see polarity, and poles mean separation of charge as you'd have in a magnet, or as we have at the North and South Pole, or with a compass. And so we see North and South Pole oriented. We see magnetic patterns for the Earth. And we see it in an oxygen molecule with its 6 valence electrons, and hydrogen with its 1 valence electron. And as they move close, they share those electrons. And yet they're not shared individually, but in pairs. And yet they're not shared in pairs evenly, but more closely to the oxygen. And in being closer to the oxygen, it makes the oxygen a little bit more negative. And you have what's called a dipole moment. And you get an area of negative charge on the bottom, and an area of positive charge on the top, which orients our molecule much like this, looking much like our magnet and our poles of north and south, similar to our friend Mickey Mouse, who loves water. And so we see these bonds that form. They emerge through that shape of water. This will be a little show and tell where we'll pass around some water molecules. But what we'll see is that they actually stick to each other, right? Because of the attraction of the positive region and the negative region, they can connect. And those bonds act to give water its structure, allow it to be both solid, liquid, and gas, unlike any other substance on Earth. We can see they stick together like glue or cohesion. Those bonds act like chains that can pull one molecule to the next. As they line up and they pull, it's enough to move water from the ground and the soil up a tree through the stems to the leaves and out into the atmosphere through transpiration. And that's what we see up in this area as the cycle continues. We see transpiration moving and capable of bringing water 300 feet without the use of any energy. Right? So you can take a peek at this redwood, look at the size of an individual in the 300 feet. Little bugs can stand on the top of water. Ice floats because it's less dense. So next piece of show and tell. So we'll pass around this ice. We see that water is able to dissolve just about anything, and it is the universal solvent, here dissolving salt. And so we ask, why do we sweat? Water allows us to cool ourselves. In losing water molecules, the water takes away heat from our bodies, and overall the temperature decreases. Water allows us to regulate pH. And so we see interdependence, and we get to emergence once again. And more rightly, the emergency. And so we look at the water crisis as the most important environmental and ecological crisis dealing in our world today. We look at the stats. Population increase, over 1 billion people without access to clean water, add another 1.5 billion to that without access to proper sanitation. You'll notice that it's not evenly distributed, and that the folks without access to clean water and to proper sanitation are primarily in Asia and Africa. Over here, without access to clean water, here's sanitation. And with dirty water comes disease. And so we can compare, overall, 71% of Earth's surface covered in water. Very, very little of that is actually accessible to us. Right? About 0.3% is fresh and accessible. If you had a 5-gallon container of water, which we do, out of this whole container, 3 teaspoons worth of water would be fresh. And so water brings with it life, and it also brings death. Over 3.5 million die a year. It works out to 1 every 15 seconds. And again, it's the children and the people in the developing world that are most affected. It'd be the equivalent of 6,000 people dying on your birthday. 160 children's classrooms a day. Many of them wiped out through cholera. What would it take to fix? $2 a day to provide 10 liters of clean water per person. And it'd be $2 for the whole year. And again, the poor are more affected than are the wealthy. We see that water problems cause more deaths than all wars. We see that water is used disproportionately in the developing versus the developed world. And the ratio would be around 1,000 to 1 for the amount of water to produce a certain amount of grain. And we see an unequal distribution even in our home. Right? The US versus the UK versus Ethiopia. Gallons per day domestically at home, so not even including agriculture. A 5-minute shower that we took this morning, more water than the average person gets to use per day. US versus the world, you could add us up. You'd need Brazil, Germany, the UK, China, Honduras, and Somalia all together to equal the individual per capita water usage. We see it here, and what would it take? Just a drop of oil, the energy in a drop of oil, to actually clean 25 liters of water. We see it first with the cycle and how we can see analogies to that and our bodies. Here we see it as a problem, right? Where we see an increase in population, an increase in contamination and pollution, and therefore a decrease in fresh water. So although it's a closed loop, it's fixed, the actual amount of fresh water is declining, and it's also a matter of timing and location. So population goes up. Here are the countries that are growing fastest. We're reminded again of the unequal distribution, contamination through factory farming, automobiles, travel, refineries. We have drugs in our water. It connects us to the mission of living water. And we see it on the cover of magazines and newspapers for the past 10 years. And so with location and timing, if you looked at it, we would be getting 10 Lake Superior's worth of fresh water rain a year. More than enough for the whole world. It's a matter of when it falls and where it falls. Right? You could see that the wet will get wetter and the dry will get drier. So it's a polarization, it's an extreming of these new catastrophes. Books being written when the rivers are dry and unquenchable. Glaciers in the Himalayas. The rains failing to come in the monsoon. Taps running dry, wells running low. And you can look at projected global water scarcity, and it's only getting worse. Even in our own country in the Southwest, they're in red. And we look at conflict and the role of water in that. Where last century was the century of oil, this century is going to be the century of water. We see it with California and Arizona and Nevada and New Mexico. You see it in Afghanistan and Somalia and Darfur. As more countries stick their straw in for an ever-decreasing amount of fresh water. And so they write the book, Water, the Epic Struggle for Wealth, Power, and Civilization, as we face these crises. And so the problems are big and they're deep. They're both environmental and they're social justice and they're ethical. And so with these problems we offer some solutions. And the Cree Indian prophecy said, only after the last tree has been cut down, only after the last fish has been caught, only after the last river has been poisoned, only then will you find money cannot be eaten. And so we offer you solutions. And if you can't read it, it says, if you're not part of the solution, you're part of the precipitate. That's a chemistry nerd joke. Ask Mr. Gaffey, he'll explain it. And so we want solutions through moderation, intelligence, and sharing. And through biomimicry, design, personal responsibility, and finally through action. And so biomimicry is to take innovation from nature. And Shakespeare said, one touch of nature makes the whole world kin. Leonardo da Vinci said, human subtlety will never devise an invention more beautiful, more simple, or more direct than does nature. Because in her inventions, nothing is lacking and nothing is superfluous. We see this wisdom over 3.5 billion years of research and design and evolution. Most famously, it's Velcro, designed after looking at birds sticking to a sock. The Wright brothers took a look at vultures flying to design their wings. You saw it in the Olympics in Beijing, Michael Phelps and other swimmers, swimsuits designed after shark skin to decrease drag. And so in our water crisis, we can see solutions through kelp as it sways and moves in the ocean. Right? You could build a device that actually harnesses that, known as the biowave. And it works through moving and oscillating and flowing and harnessing that energy into a battery. You see it in mangroves and their ability to desalinate. Mangroves exist on coasts and in brackish waters. And so they can actually pull out fresh water in areas with salt. Quite the opposite of what we saw earlier with water dissolving salt. Here it would be in reverse, from right to left. See a desalination plant here. You can work it in dams too, which oftentimes do provide electricity and water for agriculture, but too often bring with it environmental degradation. And so why not, instead of building a massive dam the size of the Three Gorges in China, why not build one after nature like a beaver, where they're intermittent and they're smaller, and yet they allow for the flow of sediment and the flow of species such as salmon and other fish. Remembering that we all live downstream. Why not drink fog as the Namibian beetle does? It's got a super hydrophobic carapace, the shell, and so it can orient itself to the wind, and as the dew and the fog come off the coast, it can stand like this. It condenses on its shell, funnels it down into its mouth, never having to drink actual liquid water. Scientists have built nets that can do just the same thing, right? You can do the same as a spider web, right? You've all seen spider webs in the morning with dew and condensation. And why not build a net that works the same way, so as to biomimetically copy or innovate based on nature's designs? You got the thorny devil, who looks cool and can drink water through its leg. Right? You can just dip it in there and can suck water up the back of its leg all the way to its mouth, which is pretty cool. You see it in the barrel cactus, all throughout the desert. Their biomimetic feature is the folds, the inner pleating, which allows for self-shading so as to decrease temperature and decrease moisture loss. Do we want to pass this one around? We can do it without stabbing each other? All right, it's sharp. But notice the folds, right? We'll start over here. Do not stab yourself. You see it in roots and water distribution, right? Plants are obviously the masters of this, as they evolved first from the oceans to the land. So in bringing the ocean within and inside, plants are the masters, right? That necessary water that they need for photosynthesis to be brought in and split by the sun is pulled up from the depths through their root system. Oftentimes it's done with their friend fungi and mycorrhizae and mutualistically, so as to increase total surface area and absorptive powers. We can connect back to transpiration one more time as we think about hydrogen bonds connecting and pulling and moving water. All right, imagine if you could run something much like an electrical cord, but instead of electrons moving through it, you've got water. And so you could build an artificial leaf that pulls and draws water up through the power of transpiration, each time ticking off energy through water molecules flowing through a pipe that mimics a leaf. And so we're back to our water cycle and the different parts as we see water moving from high to low. We see it moving from high to low concentration. Here again with transpiration. What if you took some kind of device and slapped it on the outside of a tree or on a leaf? The water that pours out of there through transpiration could be harnessed, hopefully to the effect of a cup of water every 4 hours. So it could be a lifesaver for many people in dry and water-poor regions. So we're into the personal responsibility ones, seeing some kind of light. George Bernard Shaw said, "I am of the opinion that my life belongs to the whole community. As long as I live, it is my privilege to do for it whatever I can." And so we move from water bringing life and death to water bringing just life and vigor. We're back to the solutions, to the water crisis. The numbers once more remind us. And here we have a different sort of solution. Instead of just solutions from nature and biomimicry, we've got design for the other 90%. The 90% that is not paying for big-time design. And we start with a cool little filter. For $3, it can save millions of lives. It's called a life straw. Folks can drink out of it. It can work up to a year. It filters out cholera, giardia, all sorts of waterborne diseases along with contaminants. Reminded again of the one person who dies every 15 seconds. You take a ceramic water filter, and the ceramic acts to both pull out debris and contaminants along with having antibacterial qualities. Drip irrigation systems, right, used for farming. Remember that agriculture in developing nations, look on the top there, accounts for 82% of water usage. If we could decrease that, that would be huge. So drip irrigation systems can lower it 30 to 70% while increasing yields upwards of 50%. And then you got the moneymaker hip pump, which I mostly put in there because it's got a cool name. But you can take this pump and make some money. You can dig upwards of 6 meters deep and increase water flow up to 50%. You got a bamboo treadle pump, which allows you to have a lot of fun, right? Get some exercise. People in the West would do this at their gym if they had the opportunity. Pulling up water even in the dry season, right? So we talked earlier about the importance of water coming at the right time and the right location. This allows for water to continue flowing even in the worst of times. You can see it here a little bit more close up. My favorite of all of them is the Q drum. Right? You think about the water-related issues to travel and the gender issues. Folks having to travel upwards of 5 kilometers in one direction to reach scarce water supplies. Most often women or children. Oftentimes running the risk of being attacked, robbed, mugged, killed, or raped. And so you can imagine the weight of this water. Right? Maybe we'll check it out when you're done, but 5 gallons of water is weighing just about 40 pounds. Right? So rather than carry this on your head, as many women in developing countries do, why not put it on the ground and roll it? Right? So you can get there a lot faster, much easier, and you can carry a whole lot more water. Transformation one more time. You got a pot within a pot. So take a pot, fill it with sand, wet the sand, put another pot inside of that. As the water evaporates, as we saw with Michael Jordan, the temperature goes down as we get cooled through sweating or evaporative cooling. And so you can keep produce, such as tomatoes, for weeks and weeks, and it acts like a refrigerator without ever needing electricity. And so we look at some of our own responsibility and the spin that's put on bottled water. Where'd my water bottle go? I'll use this one. For a regular size one, it's the same ratio. 1 bottle of water requires 7 bottles of water to produce it. Not to count the pollution, the fact that plastic is eternal, the oil use, and the endocrine disrupting chemicals. So maybe we should go with this for our other water challenge. It's a joke. We see the avion backwards. Coincidence? 1 million barrels of oil used. Right? That'd be the equivalent of eliminating 100,000 cars. Right? Not to mention 90% of the water bottles go unrecycled, and we recall that plastic is near eternal. We see books written about this. You compare the prices and it's not even close. A penny a gallon versus upwards of $10 a gallon. And so we see water use, and on to our water footprint. Last decade, the decade of the carbon footprint. Perhaps this new decade, the decade of the water footprint, as we examine how much water are we using in our lives. And so we see once again the U.S. in first place, right, using the most water. And so this is apart from the domestic comparison of 151 versus 30 versus 3 for the U.S. to the U.K. to Ethiopia. This is how much water is used in the food that we eat. And it's daunting. You can see a whole lot of water used for other things too. Brushing your teeth, flushing the toilet, washing dishes, washing cars, watering lawns, or eating a hamburger. For our food, it's about 500 or so gallons a day. For a kilogram of beef, right, 2.2 pounds, 16,000 liters of water. And so a hungry world must eat less meat. Even for an orange. One orange would require 28 orange juice containers worth of water to produce. White versus wheat, 40 to 28. That hamburger, 2,400 liters of water. T-shirts, your coffee. This is most astounding, I think. 1,100 drops of water for 1 drop of coffee. You're doing a little better with tea. Chocolate is pretty high. Sugar goes high too. The lower you eat on the food chain, the less water you'll need. Even the paper that we use needs quite a bit of water to process. And so action. We've got our Lenten Water Challenge. How many of y'all have taken that already? Well, that's not so good. All right, maybe we could increase that today or in the incoming weeks, right? And if you already have a water bottle or a glass, you can just give you $3 and donate it, or give a water bottle to a friend. We connect back to our idea of simplicity, right, which covers and is permeated throughout really all of our Ignatian values. Any of you going to see Living Water International next in the theater? All right. We'll be interested to hear how that goes. All right. Continuing the discussion, right? Maybe even on World Water Day, March 22nd. Stay tuned for some new information about that. You might remember from Advent Conspiracy, earlier around Christmas time. Looking for clean water for a healthy world. And that's it. So hopefully you thought of some questions or some discussion items or things that you'd maybe like to bring up either now or in your homeroom reflection, things for anything. What do we got? Oh man.
When we use water like in a shower or just a station, it just gets sent. Where does it get sent? Is it reused after that?
Yeah. Almost all of our water eventually is going to get used at a water treatment facility. But part of that is that the water we're using for watering plants or cars or showering is potable water. And so it's perfectly fresh and clean, and that's got to go back through the whole cycle again. For the ecology field trip, you might be able to go on that trip to the water processing plant. But yeah, we've got them here in Chicago. Eventually it's going to end up in sewers and possibly in the lake, and then it gets filtered to the water treatment, which then takes a lot of energy. But it does get reused, and that's kind of what we mean by the water cycle being fixed. You got a total amount. In truth, eventually it all gets cleaned again, and that's what we saw with the analogies to the clouds and streams and groundwater and wetlands. The earth does it for us at a huge price. It's just taking longer if we keep adding more contaminants and more people who want that water. What else? Any questions on stuff that was unclear? Ms. Doherty?
Why is their water consumption so much higher than that of Europe? What are we doing that there?
Yeah, that's a crazy question. I don't know for sure. I looked up and I tried to research that for a while, and there's really not good reason. I think the main use, again, that was the 151 versus 30 for gallons per day was domestic, and so that does include dishwashers and showers and lawns and car washing. I think it's mainly in those areas, kind of house-related issues and the scale of our homes compared to most of Europe that consumes it. But truthfully, I didn't find a solid, good answer. I know that Canada is right there with us, surprisingly. But Canada's agricultural use for water is significantly lower.
Do you know if China will consume more water than the U.S. as it continues to develop?
She asked if China is going to consume more water than the U.S. It's really the same thing that you've got for water, for oil, or carbon dioxide emissions, and that is the two most populous countries, China and India, are either just passing us or about to. And the same is true for, again, carbon dioxide emissions and for water use. So China is just with us and India is slightly behind, except they've got over 3 times as many people. So their total water use and carbon emissions are at or above, but per capita they're at around 1/3. So we're still doing a little too much. Rich?
What about the possibilities of our doing something to slow the loss of our freshwater supply in glaciers that are disappearing so fast, and which are going to cause dreadful flooding and diminution of available drinking water? Is there any possibility that we can do anything to stop that rapid loss?
That's a really good question. I would say that stuff like this would be our best bet. Education. I think a lot of people don't believe that that's happening. I think a lot of people take the water issue and maybe they back it up to the issue of glacier and ice caps melting, and then they see that that's got to be connected to climate change, and then it gets political from there, and thus they ignore everything that follows from that. Where you see that climate change on its own is a concept, it's an issue, and the implications of that are most severely water, right? So we see that even this past week with DC and the East Coast getting hammered, Vancouver with the Olympics getting unseasonably warm weather, you get extremes. And so the water cycle continues as it has for 4.5 billion years. but it continues differently from what we know, and so it's water in different places.
The use of greenhouse gases is really exacerbating the loss of those at a tremendous rate.
Absolutely. And you can even connect that to the building of dams, which wouldn't necessarily connect, but dams block sediment travel in river, which accumulates, which then ferments, and which leads to massive amounts of methane gas being released, which is a far greater greenhouse capturing gas and warming than is carbon dioxide. So absolutely, if we're going to look at water use and water issues, there's certain political means. I focus today on some of the design and the scientific or biomimetic solutions. Certainly I believe that education and awareness and kind of a different or deeper consciousness, even related to prayer, would and does have some effect, even if it is one individual or 220 individuals. Anyhow, Winston.
So, I know there are alternatives to what we eat that use less water.
Yep.
Are there alternatives to like sinks and showers, facilities that are used?
Oh, absolutely. Yeah, and it does bring up a good point in terms of, home and domestic use. There are low flow, kind of the three main things. Low flow shower heads that can cut down a whole lot of the water flow, even to half, and yet you'd still feel much the same because it gets aerated, so they put in some air with the water. You can lower flow sinks, and probably one of the main differences, certainly for the bathroom, is decreased flow toilets, to where the older toilet was at about 6 gallons. You can get ones that are about 1.2 gallons. Without going out and buying a new toilet, you can also stick a water jug in the toilet, right, in the top little container there, and that will decrease the volume that's needed. I think there's certainly newer technologies for dishwashers too, and washing machines that will use much less water. You wouldn't be counteracting that if you went out and bought a new one for only that reason, but if you needed one and it was broken, you'd certainly be better off. Yeah. Winston?
I'm just curious, what's the likelihood of that happening in the near future, or are these just proof of speculation?
Of all those devices, they're available. Go to Home Depot, you can get them. The likelihood of them increasing in number, well, much of it is you got to vote as a consumer. You got to buy stuff for change. If nobody buys them, the price doesn't go down. If there is an interest, whether it's in food or in greener technologies and products, then the price doesn't go down. Certainly there's political slants to it too, with possible tax breaks as come with, buying hybrid cars or installing solar panels or installing geothermic temperature regulating in your home. So there are tax incentives for these things, and also for the companies that produce those technologies. The degree to which that should happen, or conversely the degree to which practices or products that are harmful to the environment should be taxed, I don't know, that's a tough question. Yep.
Is our excessive water use affecting the climate in a negative way?
That's a good question. She's wondering if our excessive water use is affecting the climate in any way. I would say not directly the water use, but the things that go along with the water use would absolutely be using it. Think about, say, a shower, for instance. If you're taking a shorter versus longer shower, and again, this often gets used as the idea behind water use is showering. Certainly it's significant and important. If you're using a shower for 5 versus 10 versus 20 minutes, you're also heating that water. You're heating that water through oil or gas, which is then contributing to climate change. So just about anything you're doing involving water is either pumping that water, heating that water, moving that water, and then therefore later needing to clean or filter that water. And so that does require energy. Certainly for the personal responsibility issue, the most direct change that can be made is through diet, no doubt. Along with important climate change implications and health implications. So you're really hitting and throwing money. It's cheaper, healthier, uses less water. So the issues related to food would be the most direct. Yep, with that?
Is it true that tap water is not as clean as bottled water?
Good question. Something we were going to maybe get into, but I didn't know if I had time. She asked if tap water is really dirtier than bottled water. No. For the most part, tap water is much cleaner. Tap water is far more regulated and monitored than is bottled water, along with the fact that it's cheaper, along with the fact that it's coming from a closer area, and so its environmental impact is far lower. Unless the tap water is coming from a well that happened to be contaminated, which would be in the very, very few cases, then tap water is much better. Not to mention that somewhere around half of bottled waters actually are tap water. They just refilter them, or they put a fancy name or label on it. And then the other half are waters that are being pulled from other areas that are possibly ecologically damaged. And so, again, politically huge fights and ramifications even for our own water basin, right? We live in arguably the best freshwater area in the world with the Great Lakes and Lake Michigan. So we've got what many people want. Even to our conflict early with California and Arizona and Nevada, there are people who want to pump Lake Michigan water or carry Lake Michigan water all the way to the southwest. Doesn't make much sense. Anybody else? Paul?
Where do you see that controversy going about the states fighting for water?
Well, that's a really good question. I would say I don't know enough about it. I mean, I know that certainly the Colorado River and the Salton Sea in South California are really at the front of that battle. I know that the battle connects back to population growth, and population growth in a lot of ways in the wrong spot. You know, people wanting to move to an area, and places like Phoenix exploding in population and not having enough water to deal with it. And so it's a matter of water availability locally, along with population growth. Where that's going to go, I don't know. It reminds me certainly from the slide that we all live downstream. You know, so people damming or taking water from upstream will invariably have an effect on someone else. And seeing that we are all connected to that. But kind of legally or politically, I don't know enough about it. Ideas for talks and things that you want to bring up in your reflection? Any other actions, reflections, thoughts?
What do you think is the best solution to bring water to places like Africa and Asia?
The question was solution to bring water to Africa and Asia where it's needed most. A little bit of money.
I'll be putting on a PA in 5 minutes to dismiss you to session B. Please use this remaining 5 minutes to wrap up. Thank you.
One of my favorite stats came at a talk I heard a few years ago from Jeffrey Sachs, who's an economist, and he said, you know, that recently the United States had given $1.5 million to Somalia's Coast Guard to deal with the pirates. And he said, why isn't that money instead go to Somalia for water infrastructure? As we realize that the pirates, and in many cases extremism, comes from lack of political stability, which comes from lack of food and resources, which comes from lack of water. And so Somalia and much of the west or eastern Africa have been in severe droughts, and so without water, without food. And so building up that water infrastructure is what's probably needed most. And we even saw a small investment can equal a tremendous gain. And so the ability to clean water is that 1 drop of oil per 25 liters, 1 drop of oil per 25 liters of water. And so there is enough water. I mean, there's certainly not 150 gallons per person per day, but it's believed that 10 liters of water a day would be sufficient. And so that water is there. The ability to clean it through some of those technologies of the ceramic pot or moneymaker hip pump, or even to desalination. Certainly greener, more environmentally friendly desalination plants, so areas that are coastal, they're able to extract salt out of water, out of seawater. Right now is really expensive. It's really oil and energy intensive. But certainly newer technologies would be able to do that. You know, the cost of moving water is incredible because it's so heavy, right? A gallon of water is about 8 pounds, so to transport water over any distance is just not feasible. But also we see that those countries, because of our actions, those countries are most affected. So you get the wealth and poverty dichotomy again, where the greatest cause of a problem, whether it's through water issues or through global climate change, the ones that cause it the most are the ones that are able to deal with it best. And the ones that have the least cause are the ones that are hardest hit. Again, mostly in Asia and in Africa. Anything else? Another thing I want to mention, if there's other information or websites that you'd like, or information that was mentioned that you wanted to maybe further investigate, just let me know. You could either see me now or send me an email. Rudy? All right, I think we'll, oh wait, one more question.
About the technology to turn ocean water into fresh water, can we use that later? Do you see any potential in that?
Yeah, I mean, it's happening. There's desalination plants all over the place. I don't know the number. I mean, we've got them coastally here in the United States. There are also inland desalination plants. I mean, there's certainly thousands of them around the world. Many of them are in the Middle East, you know, much up in areas, Saudi Arabia, Oman, Egypt, United Arab Emirates, right, even up near Somalia, Ethiopia. Those countries have got plenty of it. California, you know, there's more even in the United States that are coming. Again, maybe the greater issue is decreasing the amount of energy needed to do it. Again, mimicking possibly those mangroves to do it.